title of my presentation is "Who is this?" That is easy to answer for me. I'm Stefan Bamberg, Senior Key Account Manager of Wibu-Systems, and let me allow to say one short some words of our company. We are headquartered in Karlsruhe, Germany, have experiences more than 30 years in the fields of protection, software protection, monetization, licensing of security features with our technology CodeMeter. So the real question is, and what are the challenges today? So very often we have to prove our identity in real life as well as in the industrial IoT. So we have situations like opening a bank account, registering a new vehicle, buying liquor, check-in at airports, or accessing a PC or a device where we have to show that we are really the person who is allowed to use that or to get access to something. And that's exactly what we have in the industrial field as well. So if we have to access a PC or a device, we have to make sure that we are allowed to do it, and what rights do we have here. And that's one side of the challenge in the IoT. So another challenge is, of course, to protect the application that is running on such a machine. So we have to make sure that nobody can change parameters, that nobody can tamper the application in a way that the device is not running according to the specification that is intended to have for that device. And these two parts, these two challenges, we have to face when we build up an industrial network based on IIoT. So for a reliable authentication, we need at least secure digital communication to make sure that the information that is sent from one system to another system is really secured and cannot be tampered. So on the one side, both devices have to authenticate each other and have to establish a secure communication channel. So individuals must authenticate to machines and applications. So if you want to log into a console, for example, you have to use your username and password, but also machines has to authenticate to each other or to a server that is running in the background, controlling everything. And that's other questions. Is the individual or the machine allowed to get access or to communicate with each other? And which explicit rights does an individual or a machine have at the time of access? What are the functions that I'm allowed to use? Am I only a normal user that can use the basic functionality of the device? Or am I a service technician who is allowed to have access to special functionalities of the device to change parameters, to control something in the background? And that's exactly the point that we have to take care of. So the basic principle is that's easy to understand. We have a person who wants to have access or has to prove its identity. And we have someone who controls it, and we have an authority. And the authority, for example, that's easy in the real life. There's an ID document that is issued by a country, for example, so that you have a passport that shows your identity. And if you are forced to prove the identity, you show that document to an authorized person, and this person checks the correctness and the issuer of that document. And if that is correct, then this person approves or rejects the access for example, opening a bank account. And that's the same story in the case of industrial IoT. So here we have a person who wants to access a machine or wants to have access to special functionalities. And that's the same thing. So we have a digital certificate that is issued instead of an ID document. It's issued by an authority. And it's the same story. So the digital certificate is checked by the system, by an industrial device, or by a PC, and you get access or you don't get access if the certificate is not the correct one or it is expired. That's also a point here. But we do not have an authority. We have a public key infrastructure that is necessary to keep track on the issuing of the certificates, of the approvals of the certificates. And that's the difference. So the authority is a public key infrastructure, PKI. What is a digital certificate? That's the basic of that. It binds an identity to a cryptographic key. So everything under the hood, the approvals and the checks that is based on cryptographic keys. And that is a proven approach to that. It contains information about an entity. It contains the public key of the entity. So we use here asymmetric cryptographic to make sure that the public key and private key are fitting together. It has a standardized structure, so everybody can trust on this procedure and on the certificates. It comes with a signature calculated from the certificate holders so that you can be sure that this certificate is really issued by an authority that you can trust on. It can be checked with cryptographic methods, and it can check also for the integrity that it is not tampered on the way to you, also using cryptographic methods. A PKI is really an infrastructure. It's not just a software program. That is necessary to know because you have to build something up in the sense of you have an infrastructure that cares about the certificates, that creates certificates, that you have your own certificate as a master certificate available. And it consists of a certificate authority that you have to build up. And it is hierarchically structured so that your root CA is able to create new certificates that are inherited from your root certificate, so that everybody that gets a certificate from you knows that this is really a certificate from you. And every certification authority holds a key pair, which consists of a private key and a public key to use the asymmetric cryptography on that. And a PKI, that is the main purpose of that, issues and manages these certificates. And you have to take care that nobody get access to your PKI structure because that is really the key for your complete security. And here we see again the structure of that certificate authority. So you have your root CA, you have sub CAs that you can use for several departments, for example, to distinguish between department 1, department 2, department 3, so that you really have a hierarchy to make sure that someone belongs to the right department when he wants to access a certain device or a certain PC. And that makes the complete structure very, very secure because you have in your hands who gets which certificate for which purpose. And if you don't want to have someone access a machine or a device, then you revoke such a certificate so that the person is not longer able to get access to that. And this system needs to be set up in your company to have the full control about authentication and right management of the people who are using the certificates. And of course, there are some solutions in the market, and we see here the CodeMeter chip. That CodeMeter uses the Infineon SLE97 security chip for storing such certificates and keys in a secure environment. So you are 100% sure that the keys that you deliver to the persons who use that certificates at the end of the day are best stored, technically best stored in a way that the smart card chip of Infineon stores that certificates, and you can work with the cryptographic libraries that are available with our CodeMeter sticks to hold and to manage that certificates. And you see we have that in different form factors. The storage of certificates in a hardware device is the best way to do it, because you cannot access the memory of that smart card chip. So it's the technical best way to protect the certificates on a secure anchor. And how does that work in reality? So you see, you can store that one or more certificates on such a dongle device to have different rights and certificates for several machines or machine parks, whatever you want and how you want to organize that. There are standard protocols that are used for certificates. So we go not very deep in the different functionalities, but there's a PKCS11 standard protocol, also a Microsoft cryptographic next generation API that is used on the Windows system, so that Windows systems can work with certificates as well by default. And there is, of course, the OpenSSL API that also uses such certificates and the keys to establish secure communications between systems. And what we have designed is the so-called CodeMeter certificate vault, who organizes the storage of such certificates in the secure way on the CM dongles, and supporting these different interfaces so that you can use the standard protocols, but based on a certificate that is stored in a secure memory of the Infineon SLE97 chip on our dongles. So it's easy to integrate the certificate vault using by browsers, VPNs, and email clients, because they are using the standard protocols that are mentioned above. And how does it work from the delivery side? So the certificate, the PKI, is something that you build up in your organization. Maybe you already have one. But one challenge is the delivery of these certificates of the cryptographic keys in a secure way. And that's exactly what we offer with our solution of the License Central as well. So you define the certificates, and you can deliver the certificates to the dongles of a specific person, specific groups, so that they have the certificates available on their dongles to be able to access devices or to be able to access software. And you see here, for example, the main person, the master in step one, controls the certificates and controls the delivery of the certificates to the dongles. So you really can allow the persons to get access to the internet. You get an activation key that allows the persons to activate such a certificate, including the cryptographic keys, on the dongle in a secure way. So it's an easy to deliver way to get the certificates in the secure memory of such a dongle. So here, for example, there's a dongle for machine A and machine C. So who has the dongle, who is allowed to have the dongles, can access machine A and C, but you do not have the rights to access machine B. And that's the authentication way to deliver the certificates using the License Central and the secure hardware anchors. And on the other hand, we talked about the secure communication, and we already did that with an OPC UA example here. So you have two devices, two robots here, and machine A and machine B wants to have a secure communication channel, and that can exactly be done using the dongles here, because both dongles have the certificates already delivered to the dongles itself. And with the OPC UA standard for platform independent data exchange, I'm pretty sure you know that, you can store the certificates which are already defined in the standard with an explicit library on the dongles of CodeMeter. So you put in machine A the dongle for machine A, you put in B the dongle for machine B, and they can establish on base software certificates they have. They can establish, for example, an OpenSSL, a secure OpenSSL connection between the two devices. And that's the second part. Beside the authentication to the systems, it's the second part. It's the secure communication channel between the two devices. So device machine A can check if machine B is allowed to talk with machine A, and if yes, they can establish a secure channel based on the OPC UA standard. And that was what I want to show you about the authentication. Who am I? And one last thing from my side, stay safe, whatever you access, whatever you connect, and wherever you are. So thank you very much for your attention, and have a good day.